grade. Our project is about bridges. Bridges, questions and answers information. What do you know about bridges? Bridges are structures that get people or cars across what is usually water. Why do we need bridges? We need bridges to get from one place to another quicker. What characteristics do bridges have? Some characteristics are that some have wires, some are long, and most of them have all different shapes and sizes. Where might bridges be found or used? Bridges are usually used or built on or over water. What types of bridges are there? There are arch, beam, cable stayed, suspension, tied arch, cantilever, truss, and more. How do you think the idea for fabricated bridges came about? I think fabricated bridges were made specially for more support, loading requirements, and for pedestrians. What purposes do bridges serve? The purpose for bridges are usually for transporting things over water that quicker than going around it. What factors influence what type of bridge is used in a particular region or location? The factors depend on the elevation of the region, how rocky it is, how windy it is, and more. What materials are used in bridge construction? The materials used for bridges may vary on what type of bridge you're building, but usually you need wood or a certain type of metal, nails, screws, and multiple tools, etc. Are all bridges made of the same material? Why or why not? No, because like the last question, it depends on what type of bridge you're making. Why would a bridge be made out of a specific set of materials? Because if a metal bridge is made of wood, then it might break, so they use a specific set of materials so the bridge won't collapse. What shapes are best for bridge strength? The best shapes for bridge strength are triangles because it has a strong base. What steps are needed to construct a bridge? First, you need to break the ground, then make the soil tighter. Next, pour the abutments, place the girders, plan the decking, then install the railings, paint and decor, and finally test the bridge. What types of careers are associated with bridge design and construction? Engineers, construction workers, contractors, planners, architects, site managers, government administration, economists, financial analysts, and planners, etc. Would plate tectonics or other environmental factors affect the types, placement, or materials used in bridge construction for a specific location? Yes, the exposure conditions, water depth, sea or river current, ship collision, ice, and natural disasters. How has bridge construction changed over time? The first bridges were made with natural things like logs, sticks, and wood. Then bridges evolved to be made from parallel cables with cross pieces along trees. Then there were rope bridges and tree trunks in girder fashion. After that, it was basically modern bridges. Are there any instances where soil composition would factor into bridge construction? What considerations must be taken into account when determining the type of bridge needed in a specific location? Environmental and geological concerns, hydrology, hydraulics, and roadway alignment are some of the things that workers have to take into consideration. What happens when a bridge fails? When a bridge fails, the engineers try to rebuild it using slightly different thoughts. If it doesn't work, they make a new plan. What can be done to improve a bridge if it fails? They can try to they can try a new type of bridge or use different supplies. These are my notes of what I had to label on my bridges, and the notes are: an acute angle is a degree less than 90, an obtuse angle is a degree more than 90 degrees, a right angle is a degree exactly 90 degrees, an acute triangle is a triangle with three acute angles, an obtuse triangle is a triangle with one obtuse angle, a right triangle is a triangle with one right angle. My bridges are beam, arc, truss, suspension, cantilever, and cable stayed. Our testing. Tavi and I had to test on paper bridges.
We had to use 5, 6, 8, 9, and 11-inch long bridge and 4-inch wide bridges. And we had to see how many pennies each bridge could hold and make a hypothesis on which bridge will hold the most pennies. We thought the 5-inch bridge would hold the most pennies. When we tested the bridge, this was the result. 5 inches, 50 pennies. 6 inches, 50 pennies. 8 inches, 28 pennies. 9 inches, 36 pennies. And 11 inches, 23 pennies. Questions and answers. What made this test effective? The test worked because we followed instructions carefully, so it worked. Which variable was tested? We changed how the journals were positioned so the bridge stayed. Was your hypothesis correct? Our hypothesis was correct because when we tested the bridge, the 5-inch bridge held the most pennies along with the 6-inch bridge. What are characteristics of an effective weight test? Well, cut and measure bridges, 2 of the same size journal cup and approximately 50 pennies. How we made our bridge. We used 200 standard-sized popsicle sticks and hot glue. How we designed our bridge went like this. First, I glued one stick on top of another. Then I glued the 2 sticks onto the other sticks vertically until I had a row of 10 sticks on top of another 10 sticks. We then repeated the process until we had 12 of those sticks and then glued 2 of those together until we had 6 of them. There were 4 sticks wide and 10 sticks long. Then we started on top part. Then the top part had 20 sticks long and 1 stick wide. We then glued the 4 sticks wide and 10 sticks long structures onto the 20 stick long structure, and voila, we had our bridge.
The left picture is a part where we can see the whole bridge from the bottom left corner of the bridge, and the second picture is just a picture of the front. And that's our